Hello viewers, in today's class we are going to discuss an important problem in probability, and here this problem has three parts, right? And this problem is based on the law of total probability and Bayes theorem, right? So let us first read out this question, and then we will discuss its solution, right? So here we have the problem. An insurance company believes that people can be divided into two classes, right? So people can be divided into two classes: those who are accident prone, right? And the other class is those who are not accident prone, right? So the company's statistics shows that an accident prone person will have an accident at some time within a fixed 1 year period with probability 0.6, right? So a person who is accident prone has the probability of meeting an accident is 0.6, and whereas this probability for people who are not accident prone is 0.2, right? Now the company knows that 20% of the population is accident prone, right? And now we have to answer these three problems. So let us start. Now viewers, here two concepts will be used. The first one is the law of total probability, and the other one is the Bayes theorem. So let us take the sample space S, right? And in this sample space we'll assume two events, right? So the first event corresponds to the people who are accident prone, and the other event is for the people who are not accident prone, right? So let us take E1. The event E1 is for the people who are accident prone, right? And I am writing here in short. So the event E1 represents the people who are accident prone, and E2 is the people, or are the people who are not accident prone, right? So we have defined here two events, E1 and E2, right? And here we have the sample space S, and now we are given that the company knows that 20% of the population is accident prone, and we have assumed that event E1 represents the people who are accident prone, right? So here we are given the probability of event E1, that is 20%. So we have 20 over 100, right? So 20 over 100 is the probability of getting a person in the company who is accident prone, right? And E2 is the event representing the people who are not accident prone, right? So obviously 80%, right? So 20% of the people are accident prone, so obviously 80% of the people are not accident prone. So the probability of the event E2 is 80 over 100, right? So now viewers, here let us take this sample space S. Now here we have defined two events, E1 and E2, in the sample space, right? So let us take E1 as this event and E2 as this event, right? Okay, now let us move further. Now here let us define a new event A, right? Now we have to define a new event A which denotes a new policy holder, with who meets with an accident, within a year, right? Within a year. So here we have now two events, E1 and E2. E1 is accident prone, E2 is not accident prone, and now event A is defined which includes or which represents the person or the new policy holder who meets with an accident within a year. Right now, this event A is defined with both these events, E1 and E2. Right, so A is the event which is defined on both these sets, E1 and E2. Now here a question arises, why this event A is associated with event E1 and E2, right? Because see here, event A is a new policy holder who meets with an accident within a year. Now this person may be from this class of people, that is E1, or from this class of people, E2, right? Or in other words, we can say that this new policy holder who meets with an accident within a year may be an accident prone person or not an accident prone person, right? So hence A is associated with both these events, E1 and E2, right? Therefore we can say that here the concept of the law of total probability will be used, right? So here E1 and E2, these two events are mutually exclusive and exhaustive. Now viewers, let us come to this portion of the problem. So the company's statistic shows that an accident prone person will have an accident at some time within a fixed 1 year period with probability 0.6, whereas this probability is 0.2 for a person who is not accident prone, right? So here this statement gives us the conditional probability, right? The conditional probability of event A, right? Because this event A is associated with both E1 and E2, hence here the conditional probability of A when E1 has happened is given, and similarly the conditional probability of event A when E2 has happened is also given, right? So here PA slash E1 and PA slash E2 represents the conditional probability of A with the events E1 and E2 respectively, right? So now this notation P of A slash E1, it has the significance that the probability of meeting the person with an accident within a year when the person it comes from this category, that is accident prone category, right? Similarly, P of A slash E2 represents the probability that this person A it meets with an accident when the person comes from this class of people, right? So here we are given that the accident prone person will come from the probability that is 0.6, right? So here we have 0.6 and here we have 0.2, because 0.2 is for a person who is not accident prone. So here these two quantities are given, where P of A slash E1 represents the conditional probability of a policy holder who meets with an accident, provided that he or she has come from this class of people, and P of A slash E2 represents the probability of this person A, that is a new policy holder meeting with an accident, provided that he or she has come from this class of people, that is not accident prone. So not accident prone probability is here 0.2, and accident prone probability is 0.6. So 0.6 can be written as 6 over 10, and P of A slash E2 can be written as 2 over 10, right? So now viewers, here we have said that this event A, it is associated with both these events E1 and E2, right? So this portion represents A intersection E1, right? And this portion represents A intersection E2, right? So now viewers, we have analyzed all the data which is given over here. Now let us come to these three problems one by one, right? So the first problem says that what is the probability that a new policy holder will have an accident within a year of purchasing a policy, right? So it means we have to find the probability that is P of A, right? It means since A is associated with both E1 and E2, therefore the combined probability of A with E1 and A with E2 should be there, right? So what is the probability that a new policy holder will have an accident within a year of purchasing a policy? So P of A represents that this person A, right? This person A meets with an accident, and now this person meets with an accident if either it comes from the accident prone class or from not accident prone class, right? So we have to find two probabilities. So the first one is P of A intersection E1, and other is P of A intersection E2, right? So the combined probability, that is the total probability of a new policy holder meeting with an accident within a year, is the sum of these two probabilities. So this probability is the probability that the person A meets with an accident, but he or she comes from accident prone class, and this probability shows that the person A, it meets with an accident, but he or she may come from not accident prone class, right? So now we have to find these two probabilities, and we'll add these two probabilities to get the total probability of a person A or new policy holder who meet with an accident. So now viewers, this expression, that is P of A, can be written as P of E1 intersection A plus P of E2 intersection A, right? And from the definition of conditional probability, we know that probability of E1 intersection A can be written as P of E1 multiplied the conditional probability of A when E1 has happened, right? And similarly here, P, that is probability of E2 intersection A, can be written as probability of E2 times the conditional probability of A when E2 has happened, right? So now this is this statement is known as the law of total probability, right? Now see here, P of E1 is 20 over 100, and P of A over E1 is 6 over 10, and here we have P of E2, that is 80 over 100 multiplied P of A over E2 is 2 over 10, right? Now this is 120 over 1000, this is 160 over 1000, and this is 120 plus 160 over 1000, that is 280 over 1000, and 0 get cancelled. We have 28 over 100, that is equal to 4 sevens are, this is 425, and 7 over 25, right? So here the probability that a new policy holder will have an accident within a year of purchasing a policy is given by 7 over 25, right? So viewers, this is how we solve this problem number 1, right? So here let us summarize it. See here, this event A is associated with both E1 and E2, therefore we have to find the total probability, right? So therefore this event A should be written as A intersection E1 and union A intersection E2, right? So this is the set A. Now let us come to the problem number 2, which utilizes the Bayes theorem. Now viewers, this problem second, it reads like, suppose that a new policy holder has an accident within a year of purchasing a policy, right? So what is the probability that he or she is accident prone, right? So here what we have to calculate, we have to calculate the probability of E1 over A, right? See, what is the probability that he or she is accident prone, right? And E1 represents the people who are accident prone, and here A is the event that the new policy holder meets with an accident, right? So what does this mean? It means that we have to find the probability of E1, that is accident prone people, and provided that he or she has met with an accident, right? So here we have to find out the back probability, that is the reverse probability, and for reverse probability we have to make use of Bayes theorem, right? So P E1 over A is given by P of E1 and then P of A over E1 over P of E1, P of A over E1, and here we have P of E2 times P of A over E2, right? So here we have to find this probability, right? So now this expression is written due to Bayes theorem, and we have already discussed Bayes theorem in our previous lectures, and now we can substitute the values here. So P of E1 is 20 over 100 and P of A over E1 is 6 over 10, and here P of E1 is 20 over 100 times 6 over 10. Then we have P of E2, which is 80 over 100 times 2 over 10, right? Now here we have to simplify this expression, and we have 120 over 1000, and here we have 120 over 1000 plus 160 over 1000, and this is 120 over 1000 divided by adding these two terms. So we have 280 over 1000, and these two get cancelled. We have 120 over 280, and here we have 4 3s are 4 7s are, right? So the probability of conditional probability of E1, provided that A has happened is 3 over 7. Right? Now let us come to the third problem. Now viewers, the third problem, it goes like this. Suppose that a new policy holder has an accident within a year of purchasing a policy. Now what is the probability that he or she is not accident prone? So not accident prone people are categorized by this event E2. So we have to now find E2 over A. That is the conditional probability of E2 provided that A has happened. Right? Now here in order to find out the probability of E2 over A, we have to again make use of the Bayes theorem. Right? So now we can write probability of E2 over A as the probability of E2 times probability of A over E2, and in the denominator we have probability of E2 or we can write here E1, probability of A over E1 plus probability of E2 times probability of A over E1. Right? Okay. Now we can substitute the values here. So PE2 is 80 over 100, and here we have probability of A over E2 as 2 over 10, and in the denominator we have 20 over 100 times 6 over 10, then we have 80 over 100 times 2 over 10. Right? Now we can solve this expression as we have done in the previous problem, and we'll get 4 over 7. Right? Now viewers, here we have obtained the value of the probability of E2 over A by Bayes theorem, but we can also find this probability by using the concept that the sum of the probability of E2 over A and E1 over A is equal to 1, right? Because in this sample space only two events E1 and E2 are defined, right? So the sum of the conditional probabilities of E1 and E2 when A has already happened is equal to 1, right? So P of E2 over A is equal to 1 minus P of E1 over A, that is 1 minus the probability of E1 over A is 3 over 7, and that is 7 minus 3 over 7, that is 4 over 7. So which is same as this value, right? So this is how we solve this problem by making use of the concept of the law of total probability with Bayes theorem.